بسم الله الرحمن الرحيم. We started to talk about TLS, transport layer security. We will see lots of similarities in terms of security contexts between TLS and IPsec. طبعا the main thing in TLS, the major differences in TLS is that TLS is designed to work on top of TCP, which means that TCP is connection oriented. So we would expect to have the context of connection here. It's bi-directional communication. In the case of IP, it was connectionless. So in which case IP is unreliable, connectionless. But here it's connection connection oriented. TCP is connection oriented. So we talked about TLS as a protocol stack that can be implemented inside the kernel of the operating system, in which case it's application agnostic and any application can use it from the stack built inside the operating system. Or it can be integrated in a specific application or service, like for example the browser. So TLS is implemented inside that application, okay? So as I said before, TLS is one of the most widely used security services by far because it's designed specifically to provide security services for web clients and web servers. Of course, web clients and web servers, as you can imagine, it constitutes a big part of the internet, and that's why it's very widely available. TLS is an internet standard that evolved commercially from SSL. We talked about this previously, is that it was designed originally to replace SSL. TLS was designed to replace SSL. SSL works on top of HTTP to provide security. So TLS was designed to deprecate SSL, and that's why TLS version 1.0 was not even backward compatible. Okay, so either you use SSL or you use TLS, and they are totally separate from each other. So this plan failed. It was not, done as planned. So TLS version 1.1 started to have backward compatibility with SSL. Okay, so inside the browser, if you use HTTPS, chances are you are actually using TLS 1.1. ماشي؟ طيب, TLS either provided as part, we talked about this, as underlying protocol suite inside the operating system, and which means it's transparent to any application, or it can be embedded in a specific package like browser. So this is the high level of the entire chapter. We explain the overview of this chapter from here. So basically, if we talk about, let's just talk briefly about Network 1. Okay, so a little bit of introduction about Network 1. In Network 1, we have a client and we have a server, right? And the client and server, from the transport layer point of view, they have TCP connection, and TCP connection is provides bidirectional communication. And on top of TCP, we have HTTP. Okay, HTTP within the 7-layer stack. Is in which layer?
Application.
Yeah. In 7-layer stack. HTTP accurately in the 7-layer stack represents what layer exactly? In the 7-layer, not in the 4-layer.
The session.
برافو عليك. Session layer. اللي هو session layer. Right. So, which means that HTTP, يعني session layer? Session layer facilitates the accumulation of conversation. بمعنى ان انت, if you try to buy anything from Amazon مثلا, ماشي? There is a session context that accumulates the results of the conversation between you and Amazon. بمعنى ان انت you first you see all the list of items, then you select, okay? These list of items, they get stored into the session context. ماشي? TCP does not store any information like this. But in the session context, you store all the items that you are trying to buy, okay? And you keep this conversation, it keeps accumulating things in the session context until eventually you decide to buy, in which case, خلاص, you buy. معناها the session between you and Amazon is now is done. So everything gets cleared and the session context gets cleared. ماشي? This session now may contain multiple TCP connections. These conversations, يعني each click you do, it might in fact create a new TCP connection from the transport layer point of view. واضح كده؟ But the session context accumulates all the outcomes of all these connections in a session context. Now, this is unsecure stack now. There's no security. احنا so far, this is network one. There's no security in this perspective, right? So if we need to add a security into that, we have TLS provides session level security context. So TLS here, this is TLS. This session level security context is represented by these protocols. يعني اللي هم handshake protocol, change cipherspec protocol, alert protocol, and heartbeat protocol. We'll talk about each of these protocols. And as you can see, they run in the level of HTTP, in the session level, okay? So similar to the fact that you have a session context, you have a security session context, which corresponds exactly to the security association for IPsec. For security association for IPsec also maintains the specifications of all the security algorithms and specifications that can be used for the tunnel. ماشي? For a long term. طبعا you have master key and you have dynamic keys as we talked before, and these dynamic keys they change over time. ماشي? But the security association itself maintains the security parameters for a long term. You have a question?
In TCP we have handshaking, right?
We have handshaking for the connection, yes, to establish the TCP connection. Yes, absolutely. Yes,
so
of course.
The handshaking.
No, this handshake is to exchange security parameters, not
for TLS, not TCP.
Yes, for TLS, not for TCP at all. This handshaking is different. We'll talk about it in details now. ماشي? Once the session context is constructed, اللي هو similar بالظبط اللي احنا كنا بنعمله في IKE. In IKE, again, we establish a security association. And again, this حتى security association, we said that there is a security association for the tunnel and there is a security association for the control information. فاكرين?
Yes.
Here it's the same. Actually, the alert protocol, the cipherspec is actually for control information. Okay? So the handshake protocol provides the session security context for both the TCP tunnel, okay, and also for a control traffic, okay, which is required to also report how the tunnel is actually working. Is it working fine, or there is some alert that maybe there is a security breach? ماشي?
Only in terms of security?
Yes, only in terms of security. So
Same
this alert protocol, exactly, same as we talked about in the anti-replay window factor for control tunnel, but there is some control traffic that also measures the health of how the IPsec tunnel is actually working. And if it finds that maybe there is a packet that's outside the anti-replay window, so that's an indication that maybe there is some kind of replay attack is happening. So, okay, so let's try to renew the security association altogether. ماشي? Here it's similar. So I'm trying to again map this to to the others to the other يعني standard that we have discussed, so that things will become يعني ايه conceptually easy for you, and you can have some rationale why they have all these protocols in place. So this is بقى the ايه, so the red components here constitute the security components that we have to embed or integrate with HTTP and TCP in order to make it secure. طبعا the tunnel here is represented by record protocol. So the record protocol here constitutes or represents this actual tunnel اللي هو بقى فيه actual data. So the data that is exchanged between this application here, these are applications, they are not hosts. Application to application communication, صح? Not hosts. So the record protocol here represents actually this actual red tunnel, which encrypts بقى and authenticates every single message inside the tunnel. And there is some control information which is maintained by the cipherspec protocol and the alert protocol and the heartbeat protocol. Okay, these are all control protocols which measures and monitors how the tunnel is working. Is it healthy? Is it? And we'll talk about each of these protocols in more details in the next slides. But this is just to give you a high level about what this chapter is going to explain to us. This is in a nutshell what the chapter is all about. And again, mapping this to IPsec makes it easy for us to try to relate things together. Okay, you will see some differences here that in IPsec we did not talk about the concept of a connection, because IP is not connection oriented, right? Here we will have the concept of a connection. We have a concept of a session and the concept of a connection, right? So we'll have to talk about these two in the upcoming slides. تفضل.
When you talked about application to application, you
Right.
mean port to port?
لا, هو application to application endpoint. Each application uses one port.
Yes.
ماشي. But it's an application to application. Application ده اللي هو يعني one tab in a browser is an application endpoint. We call it application endpoint. Each application endpoint, when it starts, it has to bind itself to a port if it wants to communicate outside the host. Okay, we call it حتى binding. It binds itself to a port. Okay, a port represents a socket. A socket. ماشي. A socket معناها ايه؟ buffer. A buffer that has some data segments coming to it, and these segments they have to be transmitted. Okay, so you have to have port-to-port communication, and the application when it starts has to bind itself to a port. So this is how it works. ماشي كده؟ طيب. So now we are expecting بقى to talk about each of these protocols in details, and before that we need to talk about what is the concept of a session in TLS, what is the concept of a connection in TLS. Okay, so very briefly, the handshake protocol is the one that's responsible to negotiate all the security parameters, okay, for this control protocols and for the tunnel itself. So this is the most important one. We'll talk about it in a later stage. So actually the whole thing starts from the handshake protocol. So the handshake protocol, similar to IKE كده, we have to negotiate. I have to give you I have to start by authenticating myself, and then you say, okay, so we can exchange some parameters. How about, do you have مثلا support to this algorithm? Yes, I have. Okay, so we negotiate until we reach an agreement that both of us, we have some master key. ماشي? So the end of this negotiation is that both of us, we have now a master key, which is shared. By master key, we mean it's a semi-permanent key that lasts for a long time. The master key together with some dynamic sequence, okay, it can بقى perform some dynamic keys that we call it بقى temporary keys. We can change from the master. Everything is derived from the master key. The master key is long term. ماشي? And from the master key and some random sequence that we can renew اللي هم بسميناه مثلا IV ماشي اللي هو initialization vectors, we can construct more temporary dynamic keys over time. Okay? So this طبعا احنا TCP connection okay has to belong to one session. But the session itself can construct multiple connections, as we said. By one simple click on any web page, you actually have to establish a connection, okay? And maybe you have one or two calls between the client and server, and then the TCP connection is torn down. And then you click again, you transfer to another page, it corresponds to another TCP connection. So one HTTP session might have multiple connections, okay? Similarly, so you have a session, and the session is defined by the master key, but each TCP connection will take temporary keys. Okay, will take some dynamic keys which is available only for that TCP connection. And TCP connection in that context, they turn to have short-term scope, and after this you can have dynamic, but the master key stays the same unless there's some alert بقى. Okay, so again it starts from the handshake protocol. The handshake protocol exchanges the parameters. By the end of this, you have what we call a specific parameters, set of parameters. We call them a cipher spec. We call them a cipher spec اللي هي مقابلة للسكيورتي association في الاي بي سيك. ماشي كده؟ A cipher spec is a set of security parameters for this session. Okay? Then you say, okay, so this cipher spec is pending. Okay? So I want to establish a new TCP connection. Which cipher spec I should use? So the chain cipher spec will tell you, oh, okay, so use this pending cipher spec as the current one for this connection. Okay? And then you establish another set of dynamic keys, and then you say, okay, change cipher spec to use different keys for the different connection, and so on. So this is the job of the change cipher spec. It's very, very simple protocol to say, okay, so now I'm using this particular cipher spec, which was established by the handshake. Then, طبعا, as we said, while the tunnel is working and everything, we may have some security breach, we may have something going on, and then we can report some alerts. And these alerts could be warning بقى or fatal errors. We'll talk about this. ماشي? So these are all control protocols. طب ايه بقى الهارت protocol? The heartbeat protocol ده بقى ايه؟ heartbeat معناه ايه؟ Are you alive or not? We need to exchange some messages. Yes, we need to exchange some messages just to show each other that we are alive. Why? Why do we need to do this in the context of security? What is the purpose of this in the context of security? What happens is that in the context of security بقى انت مثلا you are trying to buy everything, you are trying to buy some items from Amazon, you collected some items in the shopping cart and everything, and then you get in the checkout stage, and now you think about the implications of having to pay all this money. Okay, so you didn't say finalize, and you are waiting. Okay, you may wait for 2-3 minutes, something like that. During this, the session itself is idle. The session is idle. Okay, the problem with this is that in the context of security, the firewall, if your session is idle for a short period of time, the firewall may end this session. So if you wait مثلا for, let's say, 20 seconds or something, and then you try to do anything again, and you say, oh, okay, you have to renew you have to start from scratch. Okay, and this happens a lot if you try to use مثلا اللي هو طلبات مثلا اللي هو طلباتي ده ولا طلباتي services from outside the universe, especially from outside the universe, because you have to go through the firewall. So if you wait sometimes more than like 10 seconds, it kicks you out. That's all. Why? Because they are not using actually this heartbeat protocol. This heartbeat protocol is done for exactly this purpose. So even if the session is idle, I need to send some messages, they call them heartbeat messages, just to show the firewall that the session is still alive. Do not invalidate the session for a certain period of time. Okay, if you don't do this, the firewall will kill the session prematurely, and that's exactly what happens. Yeah, sometimes you feel like I'm still trying to enter some information, I was kicked out. The period of the session is very, very short. It doesn't really give you enough time to even enter the information.
كان الخطوط القطرية.
Yes, يعني
مدخل معلومات يعني واحد.
يا لسه
تحتاج
بدخل
5 دقائق.
تلاقي فورم كتير يعني فورم كبير يعني.
على طول.
Give me some chance يعني. في الآخر you click all of a sudden you get kicked out.
Big companies didn't know about this.
لا هم they do بس هم they يعني for security purposes they keep the time very short. ما أنت this is configurable يعني even if you send some heartbeat messages you can configure يعني you send some heartbeat messages for a certain period of time and then that's it. So by controlling this heartbeat protocol you can really give yourself enough chance to that at least the firewall will not prematurely invalidate the session. ماشي؟ خلاص كده؟ So this is the overall يعني تقريبا احنا يعني we talked briefly about everything in this chapter. يعني from now on is just details. But this is the high level picture of this whole chapter. ماشي كده؟ I like this progressive approach where you give everything كده, you give the whole picture but it's hazy, it's a little bit blurry, and then we take each part of the picture and then we try to zoom in and we try to make it clearer and clearer and so on. ماشي كده؟ طيب, this is what we have talked about. So we have the concept of TLS session, which again works in the same level as HTTP, and this is a association between a client and server for a long term. This accumulates, but not the data conversation, the security conversation, the security layer cipherspec basically. ماشي? Layer cipherspec. Define set of cryptographic security parameters, layer cipherspec, that can be shared amongst multiple connections. يبقى each session has multiple connections. يبقى this is one to many. يبقى the relationship here is one to many. ماشي? So the TLS session may contain multiple TCP connections. And TCP connection or TLS connection corresponds to the TCP connection because TCP is connection oriented, so TLS is also connection oriented. Of course, there is DTLS, اللي هو datagram TLS. We'll not talk about it here.
For the UDP.
For UDP. Datagram TLS is for UDP. And as we can expect, datagram TLS will be back connectionless والكلام ده عشان UDP is also connectionless and so on. ماشي؟ طيب, a transport for TLS connection is a transport that provides a suitable type of service. For TLS, such connection are peer-to-peer. Peer-to-peer اللي هي يعني peer-to-peer معناها one application to application endpoint. Connections are transient, as we said, they are temporary. Okay, so they use the same cipherspec but for some temporary keys. We'll talk about this. So corresponding to this, we have session state and we have connection state. Session state talks about all the security parameters that are long-term, that are valid for the entire session. And we have connection state, which again contains all the dynamic keys which change over time. For each connection, you have another set of keys which can be driven from the same security parameters. Okay, and we'll talk about how this happens. So every connection is associated with only one session. So session to connection is one to many. Any questions so far? Type. So we have the concept of session state. Okay, and session state contains set of fields One of them is the session identifier. Corresponds to what in IPsec? حد فاكر؟ This is طبعا security session identifier. Session identifier ده it's like this is like the primary key of the security session context. صح؟ Which corresponds to what? ها؟ لا اي كي اي ده لا اي كي اي ده سيرفيس. اي كي اي ده سيرفيس ده مش فيلد. اي كي اي ده انتيتي بحالها جوه الاي بي سيك which is responsible for احنا اللي هو session state ده corresponds to what in IPsec طيب؟
association.
security association صح. في security association can also we also used to have one identifier called SPI. Okay. Similarly here we have برضو session identifier which identifies that session state. We have peer certificate of course for to authenticate the client to the server or from the server to the client. Here we're talking about application to application. Yes, we don't have application to application, client to server. Yes, we don't have anything else. We have peer certificate. So the peer certificate that exists in the client, it contains the public key for. فاكرين certificates contain public key صح؟
Yes.
At the client you have the certificate that has the public key for the server, and the server you have the certificate that contains the public key for the client. So this way we can authenticate each other. Connection method. ليه بقى؟ احنا ما اتكلمناش عن we never talked about connection compression method. We never talked about compression before. Why do we need to talk about compression in the context of security? يعني what is the relationship? Why do we need to talk about compression in the context of security? Why do you think?
Maybe the data is bigger.
Okay, so what does this have to do with security? Yes, so the data is bigger, I need to make it smaller. Why?
Session time?
Session time? No. Why in security I need to make... Huh? Blocks? Blocks, yes, يعني هو ده.
blocks.
The encrypted blocks. Why do I need to make the data smaller?
The minimum from each hop to hop there is a minimum.
لا هاب ده الكلام ده داتا لينك لاير ده اللي هو الماكسيمم ترانسميشن يونت. لا ده حاجه تانية خالص. هنتكلم فوق يعني we are in the يعني it's not a hint, it's I have to say the answer. يعني the answer basically is that يعني as we have يعني observed is that encryption techniques are complex. Okay, encryption techniques are complex, and definitely the complexity is proportional to the block size. صح? The complexity is proportional to the block size. So if I make the data smaller, ماشي, I will spend less time to do encryption and to calculate the signature and to do all of these things, right? So it's in my benefit to do to compress everything. But here we have to say two things. First, compression is optional as part of the TLS. There's no mandatory requirement that you have to do compression. ماشي? It's optional. There's one thing. Second thing, what type of compression do we have here? Is it lossless or lossy compression? You know the difference between the two? يعني lossless compression, it talks about the fact that the information after compression contains the same information. I can decompress it and achieve the exact same original data again with no losses whatsoever. يعني this مثلا زي اللي هو الزip ولا الرار ولا الأشياء دي. These tools, they do a lossless compression. They don't lose any part of the data. Okay? why do I do مثلا lossy compression? Yes, I can do some lossy compression. For example, some signals, they have some redundant information. Even if I lose part of the information, it's not a problem. For certain applications, you are allowed to do some lossy compression. Okay, we don't have to talk about the details, but there are tons of applications that allows you to do a lossy compression to a certain extent. Which means that while you are compressing, you are distorting the data. بس to a certain limit. But it's fine. احنا عموما هنا the type of compression that we talk about here is a lossless compression, because we cannot afford losing any part of the data which is coming from web. ماشي؟ يعني مثلا as an example, video, if you do lossy compression for video, actually this is in fact what we do for MPEG-4, and this is lossy compression, right? You can lose part of the data for video, and you can still see the video very high quality even though there is some loss, right? So this is يعني one example of that. But here, regardless, احنا هنا we're talking about lossless compression. ماشي؟ طيب. So it's optional and it's lossless compression. طيب. Cipher spec بقى اللي هو ايه؟ اللي هو the actual algorithms and that you will use بقى for encryption, for MAC, message authentication codes, and for IVs. Okay, IVs are used for, as we said before, IVs are used actually as part of MAC for some protocols that we talk about, like HMAC or SMAC. We have to use initial vectors or initialization vectors, and also for some of the operational modes for encryption. We didn't talk about operational modes, بس في زي ما قلنا قبل كده اللي هو في cipher block chaining or counter mode or something like this. These also use initialization vectors. So initialization vectors are used for multiple purposes. So cipher spec contains the parameters for all of these. And then, of course, you have the master key. This is the most important thing. The master key can be used to drive all the other keys, the dynamic keys. So the master key, we combine it with other parameters, some random sequence, some parameters, like for example port numbers. So we can combine master key with port numbers with some random sequence and stuff like that, and generate bunch of keys from the master key. Okay, so the master key is the one that we have to make sure that it's shared between the client and the server in a secure way. Once we do this, خلاص, locally بقى we can, from the master key we can generate bunch of other keys locally by using بقى اللي هم ال pseudo random generators والكلام ده, and we can construct bunch of other dynamic keys, temporary keys dynamically بقى over time. مفيش مشكلة. It's based على الماster key, which is supposed to be hidden and secure from any attacks. So the last parameter here is what we call is resumable. يعني احنا we say that خلاص is it, يعني once when you start to click, and then at the end you want to finalize, خلاص, you want to check out and you want to finalize your purchase. So in that case, is resumable will be false. معناها خلاص the session itself is not alive anymore. So the security context is also not alive anymore. So we need to also say that the session is about to end. يعني خلاص ما فيش, there is no continuation. So if is resumable is true, معناها the session is still continuing. Session is going on. ماشي? So similar to a session state, we have connection state. We didn't talk about this in IPsec خالص. There is no connection state. But there is some keys also for IPsec, but we don't have to talk about the concept of a connection because IP is not connection oriented. So the connection state for the case of TLS بقى contains all the keys for this particular connection. ماشي? So you have server and client random sequence. This random sequence is what we can use to later on we'll talk about it in more details. This random sequence can be used to derive all these other keys together with the master key, which is بقى from the session itself.
It's like an initial vector.
لا يعني هي مش initial vector per se, بس هي random sequence كده ممكن you can combine it with the master key in order to generate some dynamic keys and temporary keys. The IV is used for special purposes. The IV is here, initialization vectors. These are separate. These are used for block cipher in cipher block chaining اللي هي mode of operation. Cipher blockchain is used for particular purposes. ماشي؟ But for all of these are some again يعني some random combination or random pattern. Okay? But these are used for different purposes. طيب so you have here بقى خد بالك احنا هنا we have the concept of a connection. A connection is you have a client and you have a server. Okay? So a connection means it's bidirectional, right? So you have traffic going this way and traffic going this way. Both of them, they belong to the same connection. Okay? So you have server write key. Server write key معناه ايه؟ You have هنا server write key. This server write key is the client read key. صح؟ يعني just the fact that it's server write key, it doesn't mean that it's a public key. No, it's a symmetric shared key. All of these keys are shared keys. There's no private key. There is no public key. The only public key that we use it for authentication law as part of the peer certificate for session. We use it once best for authentication between the client and server. But other than this, all these keys are shared keys, symmetric keys. ماشي? Which means that the server write key is in fact the client read key. And the client write key اللي هو بقى ايه؟ اللي هو client write key اللي هو هنا, which is the server read key. ماشي? So this is for Mac. These two are for Mac, صح? And these two are for the data by itself, for the encryption, صح? Because we have keys that we use for Mac, because the Mac is an encrypted signature, صح? The Mac is nothing but encrypted signature. ماشي? So we have to construct the signature and then we encrypt it. So we have the Mac secret key and you have the data key. It's the same server write key, and so you have here, but this is for Mac, and this is for the actual data, and you have IVs. ماشي? So you have this here and you have the same here. So 6 different parameters. ماشي كده؟ طيب and you have the sequence numbers. Sequence number, not random, sequence number. Okay? So this sequence, طب ما احنا عندنا we have in TCP we have sequence number, فاكرين؟
Yeah, for the.
Yeah, we use sequence number in TCP, right? For each segment we have sequence number. Why do we need to have sequence numbers here بقى؟ ها؟
Same idea.
Replay attack, برافو عليك. شوف بقى هو بيتكلم from the perspective of security. Yes, this is good. So we use this for replay attack. Why we don't have replay window?
Because it's a connection.
أيوة, because it's connection oriented and it's reliable. TCP is connection oriented and reliable, right? We don't need to have a window because we expect everything to be in order. Because it's a connection. That's why we have the connection. This is the rationale behind, right? Why we do it this way in IPsec, and we do it this way in TLS. ماشي? So here the sequence number is to mitigate the replay attack, but here we only need to maintain the sequence only. We don't need to have a window because everything is in order. Okay? واضح كده؟ تمام. طيب, so this is the session state parameters and this is the connection state parameter. These are very, very important. Other than this, we need to talk about the starting from here. We need to talk about each protocol. We talk about record protocol. Remember, record protocol is the actual tunnel. ماشي? This is the actual tunnel. This is where the data is actually encrypted, and we have the MAC. So we have confidentiality, very simple. We have confidentiality and we have integrity and message repudiation, which is both done by the MAC. صح. So here we have the MAC. So the MAC guarantees the integrity and non-repudiation. ماشي. And we have the confidentiality. So this is what the record protocol provides, really. And we will see that the header for that record protocol, which is added after the TCP header. Okay. Type. So the record protocol operation is very simple. So so you have the application data. I don't like to call this fragment. I disagree with the book. I like to call it ايه بقى؟ حد فاكر؟
Segments.
Segment. برافو عليك. Yes, segment. Because fragment has يعني a different scope, has different meaning. فاكرين fragmentation.
Yeah.
Fragmentation is done in the network layer. So here we better call names, يعني correct names. So here we're dealing with segments, not fragments.
Here we deal with the multiplexing and
Yes, exactly. Here we deal with multiplexing and so on. So this is then the actual correct name for the protocol data unit in the transport layer. We call it segment. We don't call it fragment. Type. So I take each segment and then I do compression. As you can see here, compression. Again, this is optional. Okay, it's optional. No one says that you have to do it. And in fact, we didn't talk about this for IPsec at all. Maybe here it's optional. And it's also a lossless. Okay? But when you do this, you reduce the size of the data, which makes the encryption and the MAC less complex. Okay, and this is good. Type. Then we do the compression, and the compression is different from encryption, huh?
yeah.
ماشي. So compression, and then we add the MAC first, and then we do the encryption. فاكرين in IPsec we talked about both. Is there any benefit from doing one versus the other? مفيش. يعني there's no. In IPsec they mentioned that there is a benefit that when you have the MAC done to the plain text, there is the advantage that you can store both for later reference and stuff like that, which I don't really buy so much. But يعني they talk about a special benefit. But here the standard actually does not force any sequence. So you can do the MAC first and then the encryption, or you can do the encryption and then the MAC. Doesn't matter. And then you add by the record protocol, the TLS header, which we will talk about. It's very, very simple. Very simple. حتى شايفين صغير صنطوط خالص. TCP كان فاكرين very complex. Here it's very, very simple. Talk about what's contained there. So basically, this is the header. So the header is very, very simple. يعني 2-3 يعني fields. That's all. So here is the content type. The content type here. Why do we have the content type? Because this would indicate whether what you have here is an actual data or control message. Control message بقى اللي هي زي ما احنا قلنا اللي هي بقى for alerts, for other things. ماشي. So this content type refers to whether what you have here is data or what you have here is otherwise. Major and minor version, there's no actual reason why you need to have two fields really. يعني if you have TLS version 1.1, the major will be 1 and the minor will be 1. This is what that means يعني. You see? يعني compressed length. Why do we need to have compressed length? So compressed length here refers to the length of the compressed data. Why بقى? Why? Because the actual there could be some part here that's not part of the data. What is this?
Padding.
Padding, bravo عليك. Yes, padding. So this is a padding. We use this to confuse cryptanalysis, right? So that's why we have to maintain the compressed length as part of the شوف الهيدر very, very simple. Only it should be actually 3 fields يعني. That's it. That's all we need. ماشي. And then the MAC. We add the MAC and that's it. Very, very simple. ماشي. هنا بس اوكي. So خلينا نستوب عشان